Alright, this is a follow-up to the video CKP with a secret, where we took a CKP waveform and analyzed it to identify the angular position and speed of the crankshaft to see what really is happening. Now, in the comments, Stefan asked what would happen if you use the internal picoscope functions to try to do the same. And here I'm going to show what will happen if you try to use crank function in mesh channels of picoscope. For that, I got a Windows 10 machine with the latest version of picoscope Automotive running, and here we go. We have the dataset loaded, and this is CKP on channel B. Let's try to apply the crank function. So crank B36 is our goal. We click OK, and at first it reports missing source because it is actually calculating. It takes a while to calculate this waveform because of the number of samples. It's around 6 million. So we can confirm in the task manager that the picoscope is working and working and working. And after it's finished, well, we see the result, which is a bunch of wiggles and completely unusable. Why is this happening? Well, one possibility is that this CKP waveform has too much noise. So one thing I tried, I went to channel B settings and activated the filtering at 1 kHz. Alright, what happens then? Unfortunately, the same thing. The low pass filter is indicated 1 kHz activated, but still no go. It's still just a bunch of wiggles. So the next line of defense is our good old fric function. So we will try to plot the frequency of channel B, and if we try to do that, we are going to get something that is usable plus a lot of hash, just crazy lines everywhere. Well, it's again probably because of the noise in the CKP waveform. So the next thing that I'm going to try, I'm going to apply low pass filtering first and then feed it into the frac function. And when we try to do that, we're going to get absolutely nothing. I don't know what exactly is happening, but somehow the result of the low pass function is not compatible with frac function. Nothing comes out of it. Very strange, but you know, if this is not possible, we still can do the following. We can still use the regular frac function, but enable the low pass filtering in the settings for the channel. So we see that we have low pass filtering at 5 kHz. Just a frac function is applied to channel B, and it's interesting to note that it looks like the channel B, it's not raw data, it's actually the process data by all the settings that are in the channel's settings, and only then fed to the frequency function. And then we get something that is fairly usable. So let's zoom in on it and see what it is. So we see a trace that shows some of the TDCs, the values over here. There are obviously some dropouts when there are missing teeth for the CKP waveform. That's how the frac function works, and we cannot do anything about that. However, not all TDCs are lined up because the speed of the crankshaft changes, and so the equal spaced grid here we have for the phase rulers does not identify the TDC exactly. So for example, here we should have a TDC, but the 630 line is happening to the right of it. So I guess what we can conclude is that we wouldn't be able to use a crank function of the picoscope for this data set. We would still be able to use frac function, but we first need to enable low pass filter in the channel settings, and still we wouldn't get the phase rulers exactly correctly, and that could be a lot less convincing than what we had in our video, where all the TDCs were lined up with phase rulers exactly, and it was very simple to see um, what is happening in that waveform. So here is the full story of this CKP with a secret, and now we are ready to proceed to an even more exciting example, where we are going to have not just the CKP waveform, but also the in-cylinder pressure capture. And what we are going to try to do, we are going to try to plot a pressure volume diagram, just like they have in the textbooks for steam engines. Very cool. That is the next video. I'm going to set it up as a premiere this time so that we can watch it together and you can ask questions right in real time. So this is the next video. See you then.